Good afternoon. I am Abdelrazak Marhab from the Lebanese International University, and I will be presenting our work entitled Implementation of Quadrotor Path Planning Using Fluid Flow Equations. This is the plan I'm going to follow broadly. Thousands of years ago, a Greek philosopher said, water always seeks its own level. And he was right. Actually, look at that. It's amazing. Water always can avoid any obstacle it faces. It goes above, below the obstacle, or turn around the obstacle, and always manages to go to its own goal. And this inspired me as an engineer. So it is possible to use water flow in navigation problems. So let's say that we have a drone that intends to navigate to its goal point, but the environment is full of obstacles. Is it possible to use the fluid flow or the water flow concept in the navigation problem? Let's look to the fluid mechanics first. In fluid mechanics, they model flows using source points, which produce flow in all directions, sink points, which suck the flow from the environment, and vortex points, which have curling flow, and we have also the free flow. So what if we put a vortex point in a free flow? Actually, it will avoid it. So let's return to our navigation problem. So let's say we have a drone that intends to go to its goal point. So I will put a sink point at the goal point and a source point right behind the drone. And on each obstacle, I will put a vortex point. And now I'm sure that the flow lines will go from the source point to the sink point while avoiding all obstacles. And voila, the problem is solved. Well, a lot of researchers and work use this idea, but this application is not realistic, because not all the obstacles are round or circular shape. And what about walls, and what about local minima problems? So this application or this algorithm is not realistic. So let's try to find more realistic algorithm, which is the panel method. The panel method is a numerical method to solve fluid flow problems, where all the obstacles in the environment are discretized into small segments. And these segments are called panels, thus its name, panel method. And the effect of each panel is included in the problem, and we will end up with the simple matrix inversion to find the obstacle effect on the flow. Thus, the flow behavior can be predicted. Panel method is actually an approximation method to solve problems. It's approximation, but it gives close results, acceptable results, but with outstanding computational simplicity. Scientists have seen that the flow is always tangent to the boundary of the obstacles. Thus, we can use a mathematical solution. We can say that the flow is always tangent to the boundary, so the dot product of the normal to the boundary and the flow vector is always equal to 0. If we'd like to apply the panel method, first we are going to discretize the obstacles in the environment into small panels, and then put a vortex point at each panel, and then we apply matrix inversion, or we apply first the boundary condition, which is the dot product between the normal to the boundary, and the flow vector is equal to 0. This is the boundary condition. Then we apply the boundary condition and matrix inversion, and then the problem will be solved, and the effect of each panel or each small segment on the flow will then be calculated. As you can see here, we have applied the boundary condition. So the effect of the free flow, the source found in the environment, the sink point in the environment, and the obstacle dot product with the boundary normal vector will be equal to 0. Here we know all the vectors except the Q induced, which is the effect of the obstacle on the flow, and thus using simple matrix inversion, we will be able to find Q induced. Thus, the effect of the obstacle on the flow. We have applied panel method on several complex shaped obstacles, and as you can see, we were able to calculate the flow velocity at each point in the environment. And we developed also a drone navigation algorithm in simulation first that accepts the map. The map has obstacles with red color. The sink point is in yellow. The source point is in green, and the drone location is in black. So the algorithm accepts this map and detects all the points, all the obstacles, and then applies panel method, and then gives the drone its pathway, the safe pathway that takes it towards its goal point. And we have also developed an online algorithm. So even if the environment is dynamic, so the obstacles are changing or the goal point has changed its location, we're still able to apply the online algorithm in simulation and direct the quadrotor towards its goal point. To the best of our knowledge, we are the first scientists that applied panel method experimentally on real quadrotors. We have used AR Drone 2 Quadrotor as experimental platform. We use an overhead camera at the ceiling in order to detect obstacles and some image processing techniques, and everything was done autonomously. This is how the algorithm applies. The overhead camera takes the picture of the environment, detects obstacles, discretize them, and then apply panel method and find the optimal path for the quadrotor and send the coordinates of the path to the quadrotor, which follows the path towards its goal point. And these are the experimental results with two obstacles. Again, the obstacles are in red. Here we have a video with two obstacles. As you can see, the quadrotor was successful in following the flow lines towards the goal point while avoiding all obstacles. Again, here we have only two obstacles, and everything, as you can see here, we have the path in 2D. This is the path in 2D of the experiment, and here we have the 3D path of the quadrotor in 3D. Again, we have also the environment with three obstacles. Before starting the experiment, we had applied the panel method and found the flow and provided the quadrotor with its optimal path that avoids all obstacles. And here we have the 2D path, as you can see. Okay, this is the 2D path and the 3D path of the experiment. So panel method was applied successfully on real quadrotors in navigation problem. And this was the offline algorithm. As future work, 3D version of the panel method is essential, and online version of this method is very important. But this will I think we will have some flexibility problems because the onboard PC on the drone is not very fast. Thank you very much.